Right now, behind closed doors, some of the fiercest competitors in technology, companies like AWS, Google, and Microsoft, are working together. They belong to a quiet alliance of over 40 global organizations. They are not collaborating on a consumer product. Instead, this coalition is systematically scanning the absolute lowest layers of our global digital architecture. They are combing through everything from massive telecommunications networks all the way down to the firmware embedded inside individual semiconductors. The engine driving this massive sweep is a system built by Anthropic called Claude Mythos. You cannot log in and talk to it. It is a highly restricted frontier AI model, locked away from public access. Anthropic characterizes Mythos as a significant leap in multi-step security analysis. The decision to form this coalition suggests that the model's ability to synthesize exploits has reached a level where the risk to global infrastructure outweighs any benefit of a public release. For decades, finding flaws in software meant relying on automated tools like fuzzers, which throw random data at a program to see if it crashes, or static analysis, which scans text for known coding errors. These tools are effective, but they generally only catch superficial, isolated bugs. Mythos operates differently. It reads massive codebases contextually, understanding exactly how these disparate pieces fit together. It builds a mental model of how the software behaves when it is actually running, and then systematically simulates the logic a human attacker would use to break in. Because the system achieved attacker-obeyed reasoning, Anthropic deemed its unrestricted release a severe dual-use risk. To manage this, they locked the model down under a controlled initiative called Project Glasswing. It creates a striking paradox. The exact same system designed to fortify our infrastructure is also an offensive tool with the potential to automate zero-day discovery at scale. Under this restricted preview, the model went to work. It quickly identified thousands of high-severity vulnerabilities. These are deep, complex flaws that can be chained together to compromise a system. Many were zero days, vulnerabilities that the original software creators did not even know existed. In OpenBSD, Mythos uncovered a remote crash vulnerability hidden for 27 years. In FFmpeg, a bug evaded automated testing pipelines for over a decade. Critically, it mapped Linux privilege escalation chains, tracing how an ordinary user could exploit memory errors to seize total root control. These discoveries demonstrate that frontier artificial intelligence can navigate deeply buried structural flaws that both human experts and specialized automated systems missed for decades. Finding those flaws requires a capability called multi-file reasoning. The AI goes beyond scanning a single document. It holds the architecture of massive, distributed systems and complex APIs in its memory all at once. Once it finds a weakness, the model constructs a multi-step attack path and actually generates the working proof-of-concept script needed to execute the exploit. Fortunately, the system offers a defensive counter capability. The AI automatically drafts precise, ready-to-deploy software patches. It then reviews all the vulnerabilities it found and ranks them based on their real-world exploitability and attack surface exposure. This chart reflects the market reaction following reports of the project's success. While major infrastructure providers are using Mythos to proactively patch flaws, cybersecurity stocks saw a reported dip as investors weighed the possibility that AI-native discovery could displace traditional security scanning vendors. This shifts the timeline of security operations. Triage processes that typically take weeks for human teams are being compressed into a matter of hours. If utilized as a defensive tool, Mythos-level systems could eventually eliminate entire classes of latent vulnerabilities through continuous, automated scanning and patching of global infrastructure. Yet the offensive reality is just as stark. Broad access to this level of reasoning would allow less skilled threat actors to generate elite-level exploits, drastically reducing the time it takes for a red team to penetrate a target. This disrupts the traditional zero-day broker market, the underground economy where undiscovered exploits are bought and sold. That market relies entirely on scarcity and the high technical expertise required to find deep bugs in the first place. This graph illustrates the shift in attacker economics. As AI lowers the barrier to discovery, the supply of available vulnerabilities spikes. Because these flaws are easier to find and faster to patch, the monetary value per exploit drops significantly. The true threat here is a complete upending of the basic supply and demand logic that has governed the cyber underground for decades. These shifting economics suggest a transition toward machine-speed cyber engagement. Moving forward, the strategic gap between a network defended by AI and one relying on manual processes is likely to widen. Anthropic's decision to restrict public access to Mythos sets a governance precedent. It establishes a model where release is gated by capability thresholds, requiring government-aligned safety evaluations before frontier models are deployed. That is the core tension of Claude Mythos. It functions as an unprecedented offensive multiplier while simultaneously serving as a defensive revolution. As cybersecurity moves toward an AI-native model, global security depends less on individual skill and more on access control, defensive coordination, and which side of the battlefield deploys the technology first.